Okay, hello. The goal of the lesson was not to present you guys with questions that were like impossible or felt impossible. That's not the point, right? It was to give you guys like genuine practice in how to do these. However, I can understand how that kind of got missed or misconstrued, simply due to the fact that sometimes AP classroom questions kind of exponentially rise in difficulty. So I am going to go ahead and go through like three of these questions. I don't want to do too much because if I make the video too long, I won't be able to upload it correctly. So I'm just going to kind of talk my way through these. I'm only going to do a few of the even numbered questions because again, you guys are responsible for the odd ones. So I'm going to start here with number two. So they give us G equals 5H minus H to the fifth, and they want us to find dg dt when h is 2 and dh dt is equal to 3. So I'm going to go ahead and the first thing I need to do, because I recognize I have this derivative that I'm looking for, right, or the rate of change, I'm actually going to derive both sides with respect to t. That's why I saved myself a little space over here. And again, it's called a related rates question, which is to say that when you take your derivatives, the value that you get will be defined implicitly. So because the variable here does not match the variable here, we know that g is a function of time and h is a function of time. So when we take our derivative, we'll technically have to use the chain rule, right? So it's 1 times the derivative of g with respect to t. And then over here, same idea. So it'll be, right, this is 5h, its derivative is just 5, times the derivative of h with respect to t, minus, with this one here, so this is the power rule, so it's 5h to the fourth times the derivative of h with respect to t. And then at this point, all I have to do now, because I recognize, right, so this is the thing I'm finding, this is what I need to actually solve for. And it looks like in this case, they gave us everything else, right? We have an h to plug in, we have dHdt to plug in. So we're just going to take everything. So dgdt equals 5 times 3 minus 5 times 3 to the fourth. Sorry, times 2 to the fourth. H is 2. dHdt is 3. And then from here, just order of operations, right? So dgdt, right, or the derivative of g with respect to time, it's 15 minus, what is that, 5 times 16 times 3. So that's going to give us 15 minus, that is 80 times 3, so 240, which gives me a final answer here of dg/dt is equal to a negative 225. There were no units on this question, so I don't need units for my final answer. This just lets me know that at whatever time this occurred, right, whenever h is equal to 2, the rate of change of g is negative, so it is decreasing 225 units per second. Looking at number 4 here, so this is the area formula for a triangle. So area equals 1/2 the base times the height. I'm going to find the derivative or rate of change of the area with respect to time. When the base is 7, the height is 6, the change in the base is 2, positive 2, so there's an increasing change, and the change in the height is negative 3, so there's a decreasing change. We're going to go ahead and set it up the same way. We're going to take our original formula. We're going to derive both sides here with respect to time. The important thing to recognize whenever you deal with a question like this, if you see that you have, right, dB dt and dH dt, then that means that both of these are changing with respect to time. So that, again, these are both changing. And since we're multiplying them together to get the derivative, I need to use a product rule. If one of these was like constant, then I wouldn't have to worry about doing this. But because they're both different as time goes on, then what this is going to tell us here is dA dt equals 1/2, right? The constants just come out in front. I'm just going to go piece by piece. So this is dB dt times h plus, let me be careful and put parentheses here because this 1/2 should just be in front of everything, right? Because it's just the 1/2 right here just gets pulled out to the front. Then we'll have dH dt times b. And we are almost done. Again, they don't give us any units, so I don't have to worry about those, but we're just going to take everything that we have and plug it in. So at this point, again, the way you would like explicitly read this, the derivative of the area with respect to time is 1/2 of derivative of the base with respect to time is 2. The height at this point is 6 plus the derivative of the height with respect to time is -3. And the base is 7. And then you just go through, just again, follow your order of operations. So dA dt is 1/2 of 12 minus 21. So that's -9. So the derivative of the area with respect to time is a -9/2. Again, there's no units here, but right, kind of like we said before, these should be in like square units per whatever time increment, minutes, seconds, hours, days, however long you're kind of working with it. But as long as you go through, right, just remember that like every piece needs to have something to get plugged into. I will review one of those like AP classroom questions just to kind of show you guys sometimes it's not the case that you'll always have all your numbers. You have to kind of do a rewrite, but that's what I meant before when I said sometimes the difficulty just kind of rises exponentially. Looking at this one here, so number 6, and then I'll probably stop after this one. A circular pool of water. So circle here, close enough, is expanding at a rate of 16 pi inches squared per second. So just recall, like we said before, right, inches squared, that is going to be an area unit. So I actually have the rate of change of the area of my circle already. And then the question is, at what rate is the radius expanding? So the radius should be getting bigger as well. When the radius is 4 inches, so they tell us that r equals 4. And for a visual, like a picture here, right? So maybe this is my circle. When I started out with a radius of some like length r. And then as time goes on, the circle actually gets larger. That's a terrible circle. I'm going to go ahead and cheat because I'm on a computer. So I'm just going to, copy, paste, call it a day. Just expand this. So the goal here is just to say, all right, if I started with this circle here, oops, and then I were to expand it out further. Now look at me having technical difficulties. It's okay. If I were to expand the same circle out further, there we go, possibly, sure. Take this side along with me. There we go, just to give you a complete picture. It's a little oblong, but we do what we can. So this is going to be the point in time where my radius is exactly 4 inches. So the question here is, what is the rate of change of the radius at that point in time? As you can tell, sometimes you will not have the actual value that you're working from, or rather the actual formula that you're working from. So we just need the area of a circle. So that's, again, pi r squared. We know that both of them are changing with respect to time. So I'm just going to kind of jump the step here. When you take your derivative, the rate of change of the area with respect to time is equal to 2 pi times the radius times the rate of change of the radius It is personal preference whether you want to go ahead and take the numbers that you have now and plug them in, or if you want to solve for this rate first, right? So like dividing everything by this side. I personally am not about to do all that. I'm just going to take my numbers and plug them in. So this is 16 pi equals 2 pi times 4 times the rate of change of the radius. Then this gives us 16 pi equals 8 pi times the rate of change of our radius. So then we divide everything by 8 pi and we get 2 equals, right, the rate of change of our radius, or dr dt. Now, you'll notice in the actual answer here, I have the correct number, but I do need units. Since this was in inches and seconds, that's why our final answer is 2 inches per second for the rate of change of the radius at whatever time it is, where the radius itself is equal to 4. But there you go. Again, you guys are tasked with the odd questions. If they don't expect you to know a formula, they'll give it to you. But it's, again, just to kind of show you, it's not meant to be super difficult. The process is always the same. You start with your original equation, you take the derivative with respect to time on both sides, you plug in the values that you have, and then call it a day.